So in this application of derivatives video, we are going to show how we can apply derivatives to limits by using something known as L'Hopital's rule. When I'm trying to use L'Hopital's rule, one of the things that you're going to look for is a common indeterminate form. The two we're going to focus on is 0 over 0 and infinity over infinity. Now, these other forms that you're going to see here, we will run into occasionally, but what we do is we try to rewrite those problems until they look like one of these forms of 0 over 0, infinity over infinity. So let's look at why we need to have a rule like L'Hopital's rule by just considering some things that are going to happen graphically. All right, so let's take a moment and look at a few examples of where we're going to have a limit that's going to approach 0 over 0 and how those are very different graphically. So as x approaches 0 for sine of x over x, if we just do a direct substitution and put in 0, we're going to get the sine of 0 over 0. But we know that the sine of 0 is 0, so we actually get 0 over 0. But if we look at this graphically, as x approaches 0, our graph should be approaching 1. So actually the point right there at x equals 0 would be 1. If we look from the left hand and the right hand side, we would see that we were approaching 1. If we look at the next example as x approaches 5, if we do a direct substitution, we get 25 minus 25 over 5 minus 5, which gives me 0 over 0 again. But if we look at the limit as x approaches 5, we'll see right there that the limit is approaching 5. So those are two entirely different answers, but they both had the indeterminate form of 0 over 0. Now let's look at a form where we're going to have infinity over infinity. If I look at the graph of the limit as x approaches infinity of 2x plus 1 over x minus 3, as x approaches infinity and substitute in a large number for the numerator, I'm going to get a large answer. So you would be getting infinity on the top, and on the bottom you'd also get infinity. But if you look at this graphically, as x approaches infinity, you can see that this is actually leveling out towards some number, and as it turns out, that's actually leveling off to 2. So the limit in this case would be 2. Now let's look at one more example as x approaches infinity. If we do 5x squared minus 3 over x plus 1, again, if we substitute in a large number, we're going to get infinity on the top and infinity on the bottom. But if we look at this graphically, as x approaches infinity, that graph just continues to grow. And so what happens is that actually approaches infinity. So we have two different graphs there that both have limits of infinity over infinity, but in their indeterminate form, we could not determine the answer, but if we look at it graphically, we could see that our limit would be 2 and infinity, and we're going to, again, in a minute, just look at how to solve those algebraically.